Hello guys, welcome back to my channel. In today's lesson, we are going to cover binary to hexadecimal conversion. And before we dive into the actual conversion, we need to remind ourselves what is a binary. And binaries are two digits number system, that is a 0 and 1. Just as you can see from this column, we have the binary numbers from 000 all the way to 111. While for the hexadecimal system, this is a combination of decimal numbers as well as the letters. And they start from, for the decimal numbers, they start from 0 all the way to 9, while the letters start from number 10, which is represented by A, number 11 represented by B, all the way to number 15, which is represented by letter F. So these are the steps that we take whenever we want to convert a binary number, that is a 1 and 0, to hexadecimal, that is from 0 all the way to F. So you write down the number, you arrange in bits in groups of 4. This is the most important part. You arrange. As you can see, the bits are arranged in group of 4. Then number 3, you compute the decimal equivalent of each group. Number 4, you combine the decimal numbers. And lastly, you give your answer in the base of 16, because from 0 to number F, we have 16 numbers. That's why we have, for this one, for the binary, they are always 2. That's why we always have base 2. Okay, let's dive direct to our example. Then our example number 1, we have 111. As you can see this number, it is not possible for us to get 4 bits. So what we do, the rule is very clear and you need to note on this one. When you encounter a number with less than 4 digits, what you are supposed to do, you are supposed to add a 0 to the left side if you are dealing with the integral part. Alternatively, if you are dealing with a fraction number, you are supposed to add 0 on the left hand side. So for the integral, you're supposed to add 0 on the left side. So I'm going to add another 0 on the left side since this is an integral part. Then you write your number in groups of 4. Then after you have done that, go to your table and you check the value for 0, 1, 1. 0, 1, 1, 1 is equivalent to, when you check the table of decimal or the hexadecimal. Okay, let's go direct so that you can have a comparison. So we have 0, 0. Let me try to minimize this one. So we have the value is 0, 1, 1. 0, 1, 1 is equivalent to 7. For the hexadecimal, it's supposed to give us 7. And 7 for the decimal is also supposed to be 7. Therefore, as per the instruction, you are supposed to write your answer. After you combine the decimal number, you are supposed to write your answer in base 16. So my answer will be 7. We have 7. Then the base is supposed to be 16. So that is our answer for the equation. Okay, let's move to the next number. And our next number, we have 1, 1, 0, 1, 1, 1. This is the integral. This is the integral part. When the fractional part, we have 0, 1, 1. So step number 1, you need to remember the rules. As you can see, the fractional digits, they are not enough to add to 4. So remember the rule. Whenever you're dealing with the fractional part, if the bits are less than 4, you're supposed to add a bit or the number of bits that will make your group to total to 4. So for this one, we need 1, 0. And which set are we supposed to add? The rule is you're supposed to add to the right when you're dealing with the fractional to total to 4. So this is a group of 4. Okay, let's move to the other part, which is the integral part. For the integral part, the rule is when you are dealing with digits or bits that are less than 4, you're supposed to work on the right. So let's group them in groups of 4. So we have the first bunch. Then we have 2 with 2 missing bits. So what are we supposed to do? As per the rule, if the bits are less than 4, then add 0 to the left of the bits in the integral part. So the left is supposed to be 0, 0. So we have now another badge with 4 digits. So the next step, of course, is now to write them down in group 4. And guys, as you continue to watch, don't forget to subscribe. Then the other group, we have a point, then the last bunch, 10. Then after that, the next step is to get we can use our table to get the number, the value for 0, 0, 11. This is equivalent to 3, as you can see. This is our 3. Binary to hexadecimal, so this is 3. 3, of course, is also the same as 3 in the decimal number system. So this is also 3. Then for 0, 0, 1, 1, 0, 1, 1. For this one, it's supposed to be 7, as you can see. So this is 7 and also 7. Then we have 0, 1, 1, 0. This should give us this value. The value is A. A is equivalent to 10. Therefore, this is A. So I hope up to that point we are on the same page. Okay, let's try to come up with another example which will enable us now to practice. So maybe you can try to practice with this one, assuming that you have a number like, I will write down the question, then I'll give you time to go through the whole thing. The number, trying to come up with the number. Maybe you can have a number like, let's see, I need to come up with a good number. So we have 1, 0, 1, 1, 1, 1, 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Let me confirm. So we have 1, 2, 3, 4, 5, 7, 8, 9. Okay, I think it's okay now. So you can try to come up with a group of 4. Group of 4. So we have the first batch. That is always the rule. The second batch. The fourth batch. And okay, there is one which is missing somewhere. Yeah. Then we have one there. Then another group so that we can remain with it as per equation. Just like that. So we have how many groups? We have group 1. So this is 1, this is 2, this is 3, this is 4. So you need now to come up with and here we have base 2. So try now to use the table to try to compare the two and come up with the answer. So I'll give you some 3 minutes for you to solve that question. Then I will give you the answer for that number. So 2 more minutes remaining. Just try to use the table. Let me extract the table for you. So we have the table on the other side. I hope that you had already so as you can see we have so this is our batch 1, 2, 3, 4 and etc. Just take your time. Just take your time, guys. So this is, of course, this is 5. So I'm expecting that you have added 0 here and another 0 there. Then use now the conversion table to get the value for that. This is supposed to give us f. This is giving us f 10, 11. This one is supposed to give you b. This one is supposed to give you f. Then for 0, 0, 1, 0 is supposed to give you 2, this last bunch. So the final answer should be 2 f b f f base 16. I hope you have managed to get that, which is a good sign to translate that you have been following what I've been teaching you. So maybe you can give yourself a tick, and also you can give yourself good 1 1 0 1 1 0 1 0 1 1 0 1 base 2. So this is a binary number. So we need now to convert this one into an hexadecimal number. So remember the rule. Number 1, you need to arrange your number in a group of 4. And as usual, this is very important for you to note, is that when you are trying to convert a binary number to an hexadecimal number, you are supposed to arrange from the least significant number. That is 4 for the integral part. Well, for the fractional, you are supposed to start for the fractional. It's supposed to be for this one. It's supposed to be for if the bits are less than, but maybe I will come to that later on. But for this one, let's arrange in a group of 4. So we have the first bunch. Maybe we can give this a different color. Then we have this one, another group, another color there, and lastly we have this one. Okay, give it a different color. So what we have done, we have arranged the work in a group of 4. So group number 1, we have 1 1 0 1. Okay, then 2 we have 10 10. Then we have 11 0 1. So step number 1, as usual, is to write down the number in a group of 4, which we have already done that. Okay, the next step is to get its decimal equivalent. If you look at the table that you had, let me see whether it's possible to get the other number. Okay, let's try to get this one. Let me see whether it's possible to see the number. Okay, so what we have the value 4 1101. So we check from the table 1101 11, where is 11? This one 11 is equivalent to 13. This is 13, and 13 for the decimal number we have decimal equivalent, but for the hexadecimal, this one it's equivalent to D. Maybe you can count. We have 1 2 3 4 5 6 8 9 10 11 12. Supposed to be it's supposed to be it's supposed to give us a 1 2 3 4 5 6 7 8 9 10 11 12 then 13. So it's supposed to give us the letter D. Well, for the 1010, where is the 1010? This is the 1010. If you look at the hexadecimal to binary, it's supposed to give us a value of A. So this one is supposed to be A. A is equivalent to 10, while 11 is 11, 1101 is supposed to give us a value of 13, the decimal, which is equivalent to D. So we have already now the solution for the whole thing. So we have 1 1 is equal to D, 10 10 is to A, 11 is to D. Now after that, the next step is to write the answer, which is supposed to be D, then the base 16, supposed to give us the base 16. So we have is supposed to be base 16. So that is now the answer. So this one, the binary 1101 10 10 1101 is equivalent to DAD16, which is our hexadecimal. And don't forget that whenever you are writing your answer in hexadecimal form, you must include the base 16 because that's now the value for it. Okay, let's move to the next part. The next example, we have this one. As you can see, we have integral parts on this side and the fractional part on the other side. So number 1, you have to confirm whether you can get a group of 3. And as you can see, it is not totaling to a group of 4. So you need to note this one. If the bits are less than 4, then you are supposed to add 0 to the left of the bits, of the integral part. So this is our integral part. So you're supposed to add other bits for it to total to 4. While on the other side, on the right of the bit for the fractional part, to make it to be 4 bits. So if you look at this one, we have the first group. Okay, let me do that. Then another group, it's missing. It also have an extra 0. So you are supposed to add 3 to total to 4. I hope up to that point we have together. If the bits are not totaling to 4, you need to work and add. Okay, let me do this. Okay, for the yellow part, as you can see, this is our integral part. You are supposed to add towards the left. But for the fractional part, you're supposed to add towards the right hand side. I hope up to that point we are together. Okay, having that done that, the next step is to write down the numbers. Then these one, I'm trying to paste. Then here we have the point. Then these one. Okay, having done that, let me do this. Okay, the next step is to get the decimal equivalent. The decimal equivalent for 000 is actually 0, and this is equivalent to 0, a normal 0. Then we have this one 111. As you can see, let me try to get the other table. So we have a 111 11. This is our 11. 11 is equivalent to 15. So this is equivalent to 15, and 15 is equivalent to this. As you can see from my table, this is 111 is equivalent to F. Then this one, we have the 000, which is as usual supposed to give us 0, and the 0 is 000. So this is 0, which should give us also the 0. Okay, having done that, the next step is now to write the answer, and our answer is supposed to be, let me do this. The answer is supposed to be 0 point. Don't forget the point. This is the point where we have the point. That's where we have our point. Then we have F and 0. Then we give to the base. Remember the rules for the base. The base is supposed to be base 16. Base 16, just like that. So those are the rules that we follow. What you should have noted by now is that when you are working with a number with less than 4 bits and you want to convert it from binary to hexadecimal, for the fractional part, you had the zeros on the right side, while on the integral parts, you had zeros on the left side. So that's the most important part for this one. Up to that point, we had together. So you can use the example that we have to navigate through this particular concept. Now for your exercise, you can try to practice with this one. You group it in a group of 4, and if they are not enough, try to add another 0, factoring in the factors that, or the rule that I've already highlighted to you. And you should get this is the answer to confirm whether you have done the right thing. This should be your answer. Maybe I might give you time to go through, so which is AC.E16. That's our answer 16. This is our 16. Is 16. So I'll give you maybe some few minutes to go through your work, then I will do it. So there goes my working. Maybe you can use this table to do the conversion. So I hope by now you are through with the working. So if you are not sure or you are still having challenge on how to go about it, you can check my next video. So thank you for taking time to watch. Don't forget to subscribe, and if you have any question regarding the conversion, kindly write it down on the comment section. I will get back to you, and I know and I believe that I will be able to help you to get this particular concept. Thank you. Don't forget to subscribe. Bye bye.